Alright, hey everybody. So this is going to be a very quick video. I want to show you an example of how we could also potentially load up a data frame faster using a other package that's been compared to pandas called polars. So polars is, they say, data frames for the new era. And it essentially is a faster version of pandas. It is one alternative of about a dozen that we could potentially use when dealing with larger data. So in one of the past videos when we were working with the SPARCS data set, so the discharge data for the state of New York, we saw that it had about 2.1 million rows, and it took approximately six to 6.5 seconds for the data to be read and sort of loaded into a Python environment. So what we'll sort of look at is just do a quick little speed comparison and see how long it takes to work and load the SPARCS data set using not pandas but polars. All right, so what I'll do here is I've just created a new little Python file that we'll use called pandas or polars. I believe that's how you pronounce it, and I might have misspelled it. No, it's polars, yeah. So let's create a simple little requirements.txt file here just for review of some basic stuff. Once we're in here, maybe I will create a new virtual environment. I'll do this the manual way here quickly. So I'll navigate to the folder. So I'm in SPARCS. Then once I'm in here, we could say Python 3.11 or Python 3 or Python, however your computer is set up, Python M, VMV, VMV. This is going to then create, a virtual environment for us, and then once that has finished, we will then activate it. So we'll then say source VMV bin activate, and now in the terminal we see that's activated, and then from here we could then say pip install recursive requirements.txt. And then what this will then do is it's going to install whatever we have here in the requirements.txt file, which is polars and pandas. We'll just give that a second. And while that's thinking, so I'm going to go ahead and start typing this. All right, and what's our data file? We'll also import time. So the data file location, I'm just going to copy the relative path there. And we'll say, we'll start first with pandas. I'm just going to let our autocomplete helpers here kind of guide through this. Again, what I have installed here to make this code kind of complete itself is GitHub Copilot. Very nifty tool. All right, and let's make sure that Polar is installed. So you guys won't need to go through and do this. It's just because I set it up a specific way here. All right, so we'll load this up. Let's give it a second here. There's pandas. Polars, this might take a second here. Great. Time. This is our location. All right, so before, when we loaded this with pandas, I believe it took, again, about 6 point some seconds. We'll see how long this takes. Oh, a little bit longer now, about 9 seconds. All right, and then we'll say with polars, we'll do the same thing. And the neat thing with polars is that a lot of the functions are called the same stuff. So in pandas, there's a read CSV, and polars, there's a read CSV. There's value counts, there's descriptive. So they've tried to make the functions or the APIs, whatever you want to call them, quite similar between the two packages. All right, so, and let's now, again, sort of load this up, but with polars. Wow, almost instantaneous, right? To load with polars 2.1 million rows took 2 milliseconds. To load it with standard pandas. Oh, let's see. Did it run into an error here? Yeah, looks like it ran into an error, which is why I went so quickly. And what is the error here? Read CSV, could not parse some column length of stay. Okay, so we just gotta make sure that length of stay gets treated as a string. Because I think what it's trying to do is it's trying to say it's an integer, which it probably is. And here it actually, I haven't used polars in a little bit. It's giving us some different options that we have. We could infer the schema length, setting that. We could use the correct dtype for that one, which we could just kind of force it to be a string. We could ignore errors, or we could add 120 to null value list. So what we'll do is probably, I think, which would be best, is we'll define the dtype for that specific column. So the column here is called length of stay. And then here, let's see if we can let this auto-complete. Dtypes for length of stay should be a string. So then we'll modify this a little bit. Cool, it's a dtype, and it looks like this is just a key value pair here, or a dictionary. So let's see if this works, or if we get another error. Looks like probably another one because it ran so quickly. And oh, got an unexpected dtype. Schema. So it might be within the schema. Infer schema. Yeah. So I bet it's within schema. And then a schema dictionary. Let's just double check here. So again, important thing here is we understand how to read the error messages. So it looks like this is actually once the data has already been loaded. So that's not helpful for us. What we want to focus on is when we're reading in the data. So input, output, read CSV. Yeah. All right. So it looks like there's something called categorical. So maybe that sets it as a string. So let's try that. Cool, that worked. So now if we look at that df, just to be sure that it loaded, yeah, cool. So, right, when we do it this way, it loads all 2.1 million rows in 1.3 seconds versus when we do it with pandas, thinking, still thinking, now it's beginning to read stuff, 2.1 million rows in about 9.9 seconds. So a lot longer. So again, Polar is a very interesting tool if we're dealing with larger data, and that's it for this short little video.